In this video, I'll be updating you on the status of my project on the Hubway data. If you recall, in my previous video, I shared with you the progress done so far on the data analytics part of the project. And this video, I'll be focusing more on the simulation part of the project. In the previous video, we have shown the results of our data analytics to find the annual commute trends of the 2016 Hubway data. Since we now have the annual commute trends for weekdays and weekends, we next pick a weekday and a weekend from our pool of 365 days to do the simulation with. We picked days having hourly trip counts close to the annual average computed previously, so that the simulation behavior would reflect the annual average behavior of the riders. The weekday and weekend days that were close to the behavior of the annual average were both in the month of October. We next extracted all the trip data needed for those 2 days out of the raw 1.2 million trip entries. We constructed 2 JSON files to be used in the simulation, one for the weekday and one for the weekend. The weekday data consisted of around 4,000 bike trips, while the weekend data was around 2,000 bike trips. The following technologies were used in this part of the project to prepare for the simulation: Leaflet as the base of our interactive geospatial map, Mapbox as our source for map tile layers, D3 to read and process the JSON data files, Leaflet time dimension library for time stepping during the simulation, and finally D3 to do the actual bike simulation and animation. The layered architecture diagram for the code looks like this. First, the data layer is responsible for reading the CSV raw file containing the 1.2 million trip entries. It extracts the trip data needed to simulate the typical weekday and weekend in 2 JSON files, which are needed during the simulation. Second, the logic layer sets up the initial map view around the Boston area. It also draws the bike stations on the base map using the station's GPS coordinates. Third and finally, the presentation layer provides an HTML interface that allows the user to choose options for the simulation, as well as starting and stopping the simulation. The simulation takes place on the leaflet map and it is controlled by a time-stepping mechanism. For layers 1 and 2, everything is pretty much my code, while for layer 3, the HTML interface is my code. Plus I used the leaflet time dimension open source library to implement the time-stepping controller. Next, we show a demo of what the map produced looks so far. We are able to successfully set up the leaflet base map with the initial view around the Boston area. We also successfully used D3 to draw the 180 plus bike stations based on their GPS coordinates, and also color coded them based on their municipals. The positions of the stations also get recalculated and scaled as we zoom in or out of the map, also when resizing the browser. This mechanism converts the latitude and longitude GPS coordinates into a simple XY coordinates in the SVG space, which corresponds to the current view of the map. This recalculation of the station coordinates is crucial as we need it for the simulation part. As for risk updates, one of our initial risks was the difficulty of learning D3 to do simulation in a short period of time. So far, we've went through a lot of online tutorials and examples to mitigate this risk, and we're able to successfully use D3 to draw static scaling SVG elements like the bike stations. So the more challenging risk is yet to come when we try to do the dynamic animation and simulation. In addition, a new risk has surfaced related to the time-stepping library we were planning to use for the simulation. Initially, we proposed using an open source library called Chronotin, which is user-friendly. However, after using it for the past few days, the library had several flaws in terms of producing inconsistent time-stepping results. To mitigate this, we ended up using another library called the Leaflet Time Dimension library, which is more robust. However, it's less user-friendly when it comes to setup and usage. For the next steps, we will be focusing on simulating the bike trips for both weekdays and weekends on the map. This will relatively be the most challenging part of the project, as it heavily relies on D3 and its animation capabilities. The next video will be covering this in more details.